This is Ravza.
And this is Beza.
Welcome to Fun Facts with RMV. Today we're going to be sharing with you all some fun facts about insects.
An insect? Where?
There aren't any insects here, Beza, but we will be traveling into their small and absolutely amazing worlds.
Oh.
Are you scared of insects?
No, not at all. I even have a fun fact about them right now.
All right then, let's hear it.
Did you know that fruit flies were the first living creatures to be sent into space?
No way! How did it fly all the way up there?
They didn't. On February 20, 1947, the humble fruit fly boldly went where no Earth creature had gone before. The historic trip was made on a rocket originally designed by the Nazis, and fruit flies are still commonly used in space research today.
But why dragonflies?
Genetically, their species has way more in common with humans than you might think. Around 75% of all the disease-causing genes present in humans have analogs in the fruit fly's genetic code. Studying fruit flies can therefore teach us a lot about our own genetic makeup, which is a big reason the insects are so popular amongst biological researchers. It's also the reason they were sent to the outer space before any humans.
Wow, who would have thought fruit flies of all animals would be similar to us in that way?
I know, right? Now here is a more extensive video for you all.
All right then.
Fruit flies are bug-eyed and spindly. They love rotten bananas and following orders from their pin-sized brains. They can lay hundreds of eggs every day. We have a lot in common? Genetically speaking, people and fruit flies are surprisingly alike, explains biologist Sharmila Bhattacharya of NASA's Ames Research Center. About 77% of known human disease genes have a recognizable match in the genetic code of fruit flies, and 50% of fly protein sequences have mammalian analogs. That's why fruit flies, known to scientists as Drosophila melanogaster, are commonplace in genetic research labs. They can be good substitutes for people. They reproduce quickly, so many generations can be studied in a short time, and their genome has been completely mapped. Drosophila is being used as a genetic model for several human diseases, including Parkinson's and Huntington's. They're about to become genetic models for astronauts. We are sending fruit flies to the International Space Station, says Bhattacharya. They will orbit Earth alongside astronauts, helping us explore the effects of long-term spaceflight on human beings. The flies will be living in a habitat developed at Ames called the Fruit Fly Lab. Inside, they will lead the hurried lives of fruit flies, living, dying, reproducing, and experiencing the same space radiation and microgravity as their human counterparts. Cameras will record the behavior and appearance of these miniature astronauts, and at intervals, some of them will be frozen and returned to Earth for analysis. Although fruit flies are bug-eyed and funny-looking, this is serious work recommended by the National Research Council itself. In a recent decadal survey, the Council noted that model systems offer increasingly valuable insight into basic biology, and they called for an organized effort to identify common changes in gene expression among key model systems in space. The Fruit Fly Lab will allow us to look into a variety of questions such as the effect of spaceflight on aging, cardiovascular fitness, sleep, stress, and much more, she says. Bhattacharya's personal interest is the immune system. It has long been known that astronauts' ability to resist disease is weakened in space. Turns out, the same thing happens to fruit flies. We sent Drosophila to Earth orbit onboard Space Shuttle Discovery in 2006, and they all experienced a decrement in immune function, says Bhattacharya. The shuttle flight was relatively brief, only 13 days, but astronauts traveling to Mars and other distant places will be in space much longer. A fruit fly habitat permanently installed on the space station allows researchers to conduct studies directly relevant to such long-duration spaceflight. Immune system studies of human astronauts can be tricky because every astronaut has his or her own idiosyncratic genetic code. What's nice about the flies we send up is that they are all genetically identical, notes Bhattacharya. We can do much better science with such a population. Flies on board the space station will also have their own carnival ride. A 1G centrifuge will subject Drosophila to the equivalent of Earth gravity, allowing researchers for the first time to unravel the competing influences of radiation and gravity. This is cutting-edge research, she says, clearly enthusiastic about this new device. The Fruit Fly Lab is scheduled to launch on board the 5th SpaceX commercial resupply mission. Maybe they should pack some bananas too.
Honestly, that is so amazing.
Well, of course it is. That is why I shared it with you all.
But I bet everyone will find this specific fun fact that I have even more interesting.
Okay, let's hear it then.
Did you know that only one dung beetle can drag 1,141 times its weight? That's like a human pulling 6 double-decker buses.
What are dung beetles? I've never heard of them before.
Well, true to their name, dung beetles are beetles that feed on feces, meaning bodily waste. Some species of dung beetles can bury dung 2,050 times their own mass in one night. Many dung beetles, known as rollers, roll dung into round balls which are used as a food source or breeding chambers.
That is kind of gross. But why do they even have to be so strong anyway?
The scientists believe the beetle evolved such brawn because brute strength is the deciding factor in males' competition over females, which is waged as head-to-head pushing matches in dung tunnels. It is also needed for protection.
Well, good for them then.
Now tell me, Beza, have you ever wondered to yourself why the world isn't covered in poop?
No, I haven't actually.
Oh well, I'm sure some of our friends who are watching has. Of course, the answer is the very insect we are talking about right now, the dung beetle.
Somewhere near you, an animal is defecating. In fact, each day, the animal kingdom produces roughly enough dung to match the volume of water pouring over the Victoria Falls. So why isn't the planet covered in this stuff? You can thank the humble dung beetle for eating up the excess. Capable of burying 250 times their body weight in a single night, these valiant insects make quick work of an endless stream of feces. Over 7,000 known species of dung beetle run cleanup duty across 6 continents, everywhere except Antarctica. A dung beetle's first task is to locate dung. Some live on the anal regions of larger animals, ready to leap off when they defecate. Others sniff out feces that animals leave behind. A pile of elephant dung can attract 4,000 beetles in 15 minutes. So once a beetle finds dung, it must work quickly to secure some of the bounty for itself. Most dung beetle species fall into one of 3 main groups: rollers, tunnelers, and dwellers. Dung rollers sculpt a ball of dung and, using their back legs, quickly roll it away from competitors. Potential partners jump on the ball, and once the ball maker has selected their mate, the pair dig their dung ball into the soil. Once it's been buried, the female lays a single egg within the dung ball. Tunnelers have a different approach. Digging underneath a pat, some drag dung down into the soil and pack it into clumps known as brood balls, dung balls, or dung sausages, depending on their shape and size. Male tunnelers sport a spectacular array of horns to fight each other for control of these tunnels, which they then defend until the female's laid her egg. Some male tunnelers avoid the fray by masquerading as hornless females and sneaking into tunnels to mate while the guardians' heads are turned. The third group of dung beetles, dwellers, take the most straightforward approach, laying their eggs directly into a dung pat. This makes their offspring more vulnerable to predation than those of the tunnelers and rollers. As the larvae feed, they riddle the dung pat with tunnels, leaving remains that are quickly colonized by bacteria and fungi and weathered away. Inside a tunnel, ball, or pat, once the larvae hatch, they consume the dung before metamorphosing into a pupa and then an adult beetle. Besides clearing dung, the actions of these beetles have considerable ecological importance. For one, they serve as secondary seed dispersers. Dung from monkeys, wild pigs, and other animals is riddled with seeds from the fruits they eat. When beetles bury their dung balls, they inadvertently protect these seeds from predators and increase the likelihood they'll germinate. The advantage is so great that one South African plant has evolved to produce seeds that look and smell like dung, to trick beetles into burying them. Dung beetles also play important roles in agricultural systems. Livestock like cows and sheep produce huge amounts of dung, which contains nutrients that can benefit plants. The beetles break up the dung and tunnel it deep into the soil, bringing the nutrients into close contact with plant roots. Their services to farmers have been valued at $380 million a year in the US and £367 million a year in the UK. Dung beetles can even help us battle global warming by reducing greenhouse gas emissions associated with farming. Microbes living in oxygen-poor livestock dung produce methane, a potent greenhouse gas. But beetles oxygenate pats when they tunnel into them, preventing the microbes from producing methane. The dung beetle spreads seeds, helps farmers, and fights climate change, and accomplishes it all simply by doing its business. Maybe next time you come across some dung in the forest or a field, you'll be tempted to take a closer look.
Well, thank you, Rauza. That was a very extensive answer.
You're welcome.
All right, thankfully it is my turn now for the fun fact. Did you know that caterpillars have 12 eyes?
No way. How does that many eyes even fit that small face?
That was what I thought when I first heard that specific fun fact, and it seems caterpillars have 12 tiny eyelets that are known as stomata. These eyes are arranged in a semicircle from one side of the head to the other. The stomata help the caterpillars to identify light and darkness. However, they do not result in excellent vision, as the caterpillar is unable to see an image or visualize colors. Thus, caterpillars move blindly from one place to another.
Oh, that is unfortunate.
I agree. But there are many more interesting aspects to their life. They later turn into gorgeous butterflies, for example.
Butterflies?
Yep. Now let us watch their journey, shall we? On to the video.
How amazing. Butterflies are truly magical creatures.
Told you my facts would be better.
Okay, fine. It was cool, but now it's my turn. And you are all going to be shocked.
Yeah, we're listening.
Did you know that bulldog ants can leap 7 times the length of their bodies?
That's very impressive. Imagine if we could jump 7 times our height. I would never walk again.
Oh, it would be so fun, I agree. But
I have a question. What do you mean by bulldog ant? Is it like an ant with the head of a bulldog?
No, Beza, there are different kinds of ants. Bull ants are large, alert ants that can grow up to 40 millimeters. They have characteristic large eyes and long, slender mandibles and a potent venom-loaded sting. They have superior vision, able to track and even follow intruders from a distance of 1 meter. Many species of bull ants have bright red or orange colors on the head or bottom.
And no bulldog head.
Nope, just a larger insect with better eyesight compared to other kinds of ants.
And there are different kinds of ants. I thought they were all the same.
Here, I have an idea. I think you will understand the world of ants a lot better if you just heard the story from a little ant friend of mine. On to you, buddy.
Riddle, I bet you don't know who I am, do you? Wow, you were able to guess so fast. You're right, I am an ant, but I'll bet you don't know exactly what kind of ant I am. I'm a green tree ant, as are all those ants. We are one big, busy family. We mainly live in the forests of Australia, but we also live in other parts of the world. Other types of ants live in these woods as well. Take, for example, our neighbours, the bulldog ants, who live underground. Bulldog ants are very dangerous to us, as they are very strong. Sadly, sometimes we have to fight them. Though they are much bigger than us, we are smarter than they are. We have many proven ways to protect ourselves from the strong enemy. ants are at their best working above ground all together. We create huge communities. My family, the green tree ants, make our nests in the trees and construct the nest with leaves. Each individual ant has a specific job during the construction process. We naturally help each other. Since the leaves used for the nest building are much bigger than we are, we must work together to manipulate them. Look how organized we are. Everyone knows what to do. I've heard that humans build their nests as well. You help each other and create great structures. We build our nests so our queen can go inside and lay her eggs. When the eggs hatch, an ant larva emerges. But before it will pupate, it produces silk, which we will use to connect the leaves. The silk is used to hold our nest together. From pupas, new ants, just like me, are fully formed. I hatched a few days ago in this beautiful forest. Are you surprised that I know everything already? That's because we are born knowing everything we need to know as ants. We don't have to learn a thing. Watch out! Watch out! There's an intruder! He's hungry and wants to eat us. Hurry, hurry! We must stop him. It's a trapjaw ant! He's got huge jaws, or mandibles. Everyone at the alert! Now watch how we scare him off. When we feel threatened by an enemy, we have poison in our bodies which we spray on them. That's it! We won! Oh gosh! Now it looks like the bulldog ants want to attack us. Well, they do live really close to us. Hope they won't bother anyone. We'll have to prepare for another fight. These ants have very good eyesight. The rest of us don't see that well. That's because we don't really need to. In order to communicate and maintain orientation, we use scent traces from our bodies. When we find something to eat, we'll mark the path by leaving a scent. Other kinds of ants use different ways of communicating, such as stridulation or tasting. In our communities, our queen is the most important ant in the nest. She lays the eggs from which male ants and worker ants will come. The job of the workers is to care for our nest. They build and protect the nest against enemies. The male ants are in charge of reproduction. The workers care for our eggs and for the hatched larvae, like this bulldog ant. See? While our new nest is being built, we must be very careful that no one attacks our queen. We are very vulnerable when we are not all together. Looks like our neighbours got some secret news. I bet they are planning to do something bad to us. They saw us build a new nest, and I think they want to find out if there might be something good inside that they can eat. From the moment we finished building our nest, someone tried to sneak into our pantry. I'd better go and warn the others before it's too late. Oh gosh, another trespasser! It's a Jack Jumper ant! Attention everyone! The invaders are coming from the other side! They have very dangerous poison, so we'll have to outsmart them. The bulldog ants are paying close attention to the situation. All green tree ants gather here. The battle has now begun. Don't worry, by working together, we're sure to beat them. The transmission of signals is a very important part of winning the battle. It's over. The enemy had to retreat. Let's enjoy a bit of peace for a while. After what they saw, I would think the bulldog ants wouldn't want to attack us anymore. I hope it'll last a good while so we can concentrate on our work. Did you notice how skilled and flexible the ants are? Ants can be compared to the work of an artist. Or even a pilot. Ants are incredibly strong. We ants can carry many times our own body weight. Most humans can't do that. Just imagine, would you be able to lift someone bigger than you over your head? Would you be able to lift a few people at the same time like that? Ants are able to actually combine our individual strengths together in order to build a complex structure such as our nest. Ants are built for working long and hard. We do whatever is good for us all. When I collect food, it's always intended for everyone, not just for me. No one does anything just for himself. We don't do anything just for fun either. All of our time is spent caring for our nest. We also build many paths that lead into our nest. The ants that live in dry regions are able to carry drops of water to their anthill. I love being an amazing ant. All of us are very proud of our anthill. It seems that the bulldog ants won't try anything against us today. They're probably scared of our great combat tactics. I don't blame them. We're really good. When the fighting has stopped and the woods are peaceful, we can start to move some tasty food into the pantry of our new nest. Here it is! Look what we have found! Why are you making faces? We love it! It's so delicious! We just had different tastes from you. Take a good last look at us working together. Together, we create something no single ant would ever be able to create. And now it's time to bid you farewell. Goodbye, and don't forget your friends, the ants.
Goodbye, little ant friends! I am shocked about all that I have learned from this ant friend of yours, Ralza.
Honestly, so am I. The world of insects is even more fascinating than I imagined.
But unfortunately, it seems that we are nearing the end of the program. I hope you guys enjoyed this awesome journey into the world of insects as much as we have.
Which of these facts do you think was the most interesting? Be sure to let us know.
Thanks for watching Fun Facts with RMB. Hope you guys enjoyed it. Stay tuned to Fun Facts with RMB on TikTok. Goodbye!